Hello everyone, good day.
Hello.
So today we're going to look at week 2 and week 10 of the lesson. In the previous week, we have looked at bubble sorts from week 1 and we look at the tree data structure from week 9. Now we want to look at selection sorts and insertion sorts and then move on to looking at the binary search tree and how we balance the tree. I am not going to repeat what we did in the pre-recorded video. We're just going to try to build a real-world app to simulate the things that we have learned. Now we know that in the selection sort, when we have an array, the selection sort will find the minimum in that array and then places it in the correct position. For instance, if we have an array that has numbers, let's say 5, we have numbers 5, 3, let's say 8 and 4. If this is the selection sort, what this is going to do is to find the minimum here. The minimum is 3 and we'll look for where is the correct path to put this. So on the first pass, it's going to be like this. The minimum 3 will come to the front and then we have 5 and we have 8 and we have 4. On the second run, it will look at this and what's the minimum now, because the first part is already sorted, so we'll leave that one. It says 4. It takes 4 and put it before 5. So now it will be 3, 4, 5 and 8. So you can see that it takes 3 passes. No, sorry, it's going to be 3. It puts 4 there. Hold on. Okay, 5, 3, 8, 4. And then it finds the minimum. 3 is swaps with 5. It will be 3, 5, 8, 4. And then on the next run, it finds the minimum 4. It swaps 4 with 8. 4 with 5. So it is going to be 3, 4, 8, 5. So the swap is such that, let me not jump ahead. I want you to understand this before I write the code. It does a swap, right? It swaps with, so the first time it takes 3 as the minimum, it swaps with 5, changes position with 5. On the second run, 4 is the minimum and 4 is supposed to be where 5 is, so it swaps with 5. It doesn't just shift, but it swaps. So when 4 comes here, it now becomes 3, 4, 8, 5. All right.
Yeah.
And then the same thing. So that's what the selection sort. And so if you want to implement this, we're going to write, let's implement this in Python. Dev. I don't want this to autocomplete. Hold on, I'll have to stop and start again. Okay, so now we want to use that idea to create or to implement the selection sort. And for those in batch A, this is going to lead up onto your assignment 8. So you pay attention carefully and use this as your review. So when we start doing the lab for batch A, we're going to include the whole idea. So let's say we have the selection sort. I don't want to do it like we had it in the pre-recorded video. Let's create it in a different way with a real-world scenario in mind. Let's say you work as a junior engineer for an online marketplace. Let's use Shopify, for instance. And the company stores maybe product inventory in a list. And this list is not yet optimized. We want to implement the selection sort and we want to implement the insertion sort so that the warehouse team will be able to sort the products by the price in maybe ascending order, by the stock quantity in descending order, and then we'll look at the time complexity and compare the sorting algorithms on the real data. So we want to be able to write a clean solution and we want to be able to test them with a product data set. Now, I'm going to come to this file and let's create a data set here. Next thing, we have a data set called products. And this data set has a list of dictionary items. So let's say we have the first item is the name. And let's say this item is, so let's have every item should have a name, a price and the stock quantity so that we can use this for illustration. So let's say we have laptop. Let's have laptop sleeve, right? And we want to have the price. And let's say the price is, let's say $25.99, and let's get the quantity in stock. And let's say the quantity stock is 18. Okay, we'll have another item. I'm just going to copy this, and let's have a number of items. The next one is, let's have a keyboard. Let's say the price of this keyboard is, let's change this to $49.99, and let's say we have 12 in stock. Let's have another item. Let's say USB cable. We'll say the price is $8.99, and let's have a lot of this in stock. Let's say 150. We want to have, let's have another item. Let's say a monitor stand. Let's say the price of this is, let me stop using 99, let's say 32.50, something like that. And then let's say we have just a few in stock. And then we have, let's say, a mouse. Let me say wireless mouse. Let's put the price at $15.75, and let's say we have 30 in stock. So we have this data set. So let's assume that we are reading this from the database, and we get this as a list here, and we're going to use this list to be the data set that we want to sort. We want to write the selection sort algorithm, and we want to sort this product data set to have it in ascending order of the price. And then we want to do something like, maybe we want to print a quantity in stock in descending order, and we maybe want to print all of the product info also. Then maybe we'll write an algorithm that will compare both and see which one is faster in practice based on small data sets, and which one is better for maybe anything that is nearly sorted. All right. So we want to look at the keys that we have here. We have a key of name, price, and stock. So we know that these are the names of the keys that we want to use. So when we sort by price, the key will be price. When we sort by stock, the key will be stock. So let's do the selection sort algorithm, and let's not mutate the original, because we want to keep the original data set. We want to have a copy of it. So when you are implementing an algorithm, you don't use exactly the same algorithm like the basic one, but you have to modify it to suit the purpose of what your whole idea or what the whole requirement is. So now we want to build the selection sort, and we know that we don't want to modify the original data set. We always want to keep it. And so in our selection sort algorithm, we are going to define it very close to the other, but we want to work on a copy. So let's say def selection sort, and for the selection sort, we pass in the array and we pass in the key. So now we are building this in such a way that it suits our purpose. When we did the selection sort algorithm in the pre-recorded video, we did this like as in a general selection sort, and if you recall, we did not pass in a key, we just put in the array. But now we can see that in this scenario, we want to be able to sort by a specified key. Does everybody understand what I'm trying to do here?
Yeah.
Yes.
So whenever you are asked to use a sorting algorithm to perform a task, you are going to modify the sorting algorithm so that it suits the task that you're supposed to do. The whole fundamental method of sorting will remain the same, but it has to be modified so that you can use it for the purpose and not just a general sorting. So now we know that we want to sort by price and sort by quantity in stock, and we can decide to sort by any key, even by the name in the future. So you want to create your sorting algorithm and you want to have that criteria you want to sort by. Now, we don't want to change the original copy of this data set. So we want to create a copy. Let's say array is equal to array.copy. So we can use the copy method in list to do this. So we just copy this and then we'll work on the copy, right? So the total number or the length of the array, we'll store it in n. Now for selection sort that we illustrated, we'll say for I in range n, we want to get the minimum index. So let's say min index is equal to, we'll assume that I is the min index or whatever is pointed to by I, and we want to get an inner loop that will repeat this over and over again until it is completely sorted. So we'll say for j in range. So now we are going to put j in range I plus 1 because we don't want to do the sorted part. It always moves it to the front, right, to sort it or to the correct position. And when we say I plus 1, it means we don't want to repeat what we have done before. So it will start from I plus 1 to n. And if the element pointed to by j, so let's say if j and let's say key, because now we are sorting this based on a key. So if that element is a list and that list has items that is in dictionary, so let's look at it again. We have a dictionary we have a list that is a list of dictionary items, right? And so when we get the list, the index position 1 for the list has different keys. So we're doing it like this. So we go to the index position and we want to get the key for it. So if the key of this is less than array min index key, then we'll say min index is equal to j. And now you can see that this is a similar pattern to the selection sort algorithm that we have done previously, but we are modifying this to suit the purpose. So array I, array min index is equal to, so we're swapping array min index array I. Does everyone understand?
Yes.
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 Okay. And then now we return the array. So you see that two fundamental things. We want to work on a copy of the data set and we want to have another parameter, the key that we want to sort by here. And so in this line, we just make sure that we are comparing, we are sorting by the key. And so instead of saying array j is less than array min index, we are making sure that we are looking at we are sorting the dictionary also, the dictionary items by the key here. Now we have this selection sort. Let's implement the insertion sort. So for an insertion sort, we take elements one by one, and we insert them in the right position in a sorted path. Now, when you hear selection and insertion, it sounds confusing because you now begin to wonder what the difference is. When we illustrated selection sort, we take a minimum and we swap it with we put it in the correct position and take the one that is currently in that position to the position we are moving the minimum item from. Let's illustrate the insertion sort so we can see the difference. So for insertion, let's use the same one so that we can see. I think it was 8 and 4, right? Now, we want to see how we manually do this swap so that we can implement it. We say that we'll take the first item as the sorted part. Like so, 5, we assume that 5 is already sorted. That's the first step. The first element is already sorted. The next step is to insert the next element in the correct path, whether in front of that or behind it. We are going to compare the next with the first. So on the second run, what we'll have now is we compare 3 and 5. We now swap because 3 is lower. So put 3, 5, and the rest will remain there, 8, 4. Okay. Now, on the next one, we have 8. And we look at 8. So this part is now sorted. We look at 8 and we now say, where is 8 supposed to be? It remains in the same location. We don't need to make a swap for 8 here. Okay. So we have 3, 5, 8, 4 remaining the same on the second run. On the third run, we now look at this and say, we have 4. Where does 4 fit in here? So we know that we have to move 4 before 5 here. And then on the third run, we have 4 here before 5. And 4 is no longer here. And then it is completely sorted. So you see how it differs from the selection sort where we are not having a sorted and unsorted part. We just always look for the minimum in the whole array and put it where it belongs to. So now let's implement this with our whole idea in mind. We want to make sure that we can also do a sorting in reverse order. We don't only want to sort in ascending. We want to be able to sort in descending as well. So let's do that. Let's do that this way. Hold on. I want to write down what I'm doing. All right. So we have the insertion sort. We want to make sure we have the descending order sorting. There are 2 ways we can do this. We can either compare when we get to the comparison and see if it is less than or if it is greater than, or we can just add an option. Who can tell me what the option is? Here, when we say def insertion sort, and we want to pass in the array, the key, and another option here. Can anybody guess what that option will be? We use that in the sort function in Python.
Like how we want to arrange ascending or descending?
Yeah, we want to sort in ascending and descending. What is that keyword that we can add there to make that happen?
Sort. Dot sort.
You say what?
Dot sort.
Yes, we use sort, but we're not using dot sort. But there's a parameter we use with the sort function that we can add there. Okay, I'll make it easy, and we know we always use reverse. So when we want to sort in descending order, when we use the sort function, we always have this reverse. So we can say reverse equal to false.
Oh,
And so whenever we call this function, we can set reverse to true if we want it in descending order. Now, does it make sense?
yes.
Yes.
So you see how practicing with real world scenario make you understand deeper how you can explore and edit the same function. So you want to know the general fundamental way that works and how is it implemented, and then you always modify your solution based on the app you are building. Okay, so let's say we want to still work on the copy of this like the other one. We're not going to modify the original. So say array is equal to array.copy, and now we'll get the length. So it's going to be fundamentally the same as the insertion sorts that we did in the pre-recorded video. And this is for week 2. So let's get for I in range. So we want to start from 1. And who can tell me why we start from 1? Anybody?
I think since we are assuming we keep the first, assuming first is sorted, kind of.
Perfect, because we say the first is sorted. So, and range starts from 0. So we'll start from 1 to the length of the array. Now, let's say the current item now is going to be wherever the I is pointing to. And we want to say J. So the sorted part now will be I minus 1, right? Where J will be pointing to the last index of the sorted part. We want to say while, let's use the while loop, while J is greater or equal to 0. So if the last index of the sorted part is not 0, that means you can actually, there are still items to sort. And so now in this AND condition, what do you want? What do you think we'll put here in the AND condition? Because now bear in mind that we have reverse equal to true, equal to false. What do we put here? Do we want to check what the value of reversed is, or we want to do something? What do we do here to make sure that this sorting algorithm can work for both ascending and descending order?
I think that
Check with the
I think-
current.
You say what?
We check with the current.
Okay, and what we check with the current? We check what with the current?
As if
The-
the array of J is greater than the current.
Okay, yeah, that's the basic part of when we are doing the normal insertion sort. But in this case where we have another parameter reverse equal to false, what do we do?
I guess check if like key is greater than array, I think.
Yes, and then what else?
And then the array is J,
And the what?
and then the array is J.
No. The
Oh.
second part is just and then you check if the reverse is false or true.
Oh,
Yeah. So if you check if while J is greater or equal to 0, which is the condition you must always check, and let's put this in parentheses because it's going to be long. We want to check if the key now, like you said, array J key is greater than the current key and not reversed. So reverse is set to false. So that means reverse is still false and not reversed. Or we want to check another condition. Okay. So we have array J key is greater than current key and not reversed. or we want to check that array J key less than current key. And so once it's less than, we want to check that it's both less than and reversed. Okay? So does it make sense now?
Yes.
Excuse me?
Yeah.
I didn't get this part, like why we are having two conditions here at same place.
Okay, now because we have this parameter reversed is equal to false, we want to be able to use this function to specify whether we want it in ascending or descending order. Now, if the inner loop now, because we have an inner loop that will continue to do this algorithm over and over again until completely sorted. Now, the current item where I is pointing to, we store in current, and J is going to be the last index of the sorted part, this I minus 1. Now, if the current is pointing at the first index position 0, 0 minus 1 is going to become minus 1. So we always want to make sure that J is greater or equal to 0 to make it valid, that we are not already pointing at the first index position, but we are starting from 1, the next index position. But if you swap and it goes to 0, you want to make sure that that condition is there. Now, because we want to always check whether we want it in ascending or descending order, we want to handle it in this while loop. So the second condition will be AND. Normally, if we don't have this reversed here and we're setting and we're having in ascending order, we'll just do the array J, the key is greater than the current key, then we would have just swapped immediately. We don't bother about this. But if the inner loop, the current item in the inner loop now, where it's pointed to, or the next the first item of the unsorted part is greater than the current item that is pointed to by the key, or the last index of the is greater than the current, well, if the current item, if the item pointed to by at the last index of the sorted part, right, is greater than the item pointed to by the outer loop, right? So the current is going to be like the current item where it's pointed to. So if the one in the next unsorted part is greater than the last of the sorted, and it is not reversed, that means we are not doing it in descending order, it's ascending order. And we want to check the other condition, that the item pointed to, that's by the inner loop, the item pointed to the first unsorted item now is less than the current item or the last index of the sorted part, and we want it to be reversed. Does it make sense now?
Yes, yeah. Now I am getting. So in the same loop, we are checking it for the ascending or descending, and we will swap accordingly.
Yes.
Okay.
So you check it for ascending and descending. So why you put a condition like this is that, so this handles it if it is in ascending order. So in ascending order, the next item must be greater than the current item, right? And in descending order, the next item must be less than the current item. So that's why I say and reversed and not reversed. So now we can now swap, right? The same swapping we'll do. So we'll say array J plus 1 is equal to array J, and we will decrement now J minus equal 1. Who can tell me why we decrement?
We are going backward in the sorted part.
Yes. And then when we do that, we are going to now say the J plus, for the outer loop now, So let's say for the outer loop now, we have array j plus 1. I hope this is correct. Is equal to, yeah. So this will be equal to the current. Now we can return array. Now, does it make sense?
Yes.
The logic is a little complicated to think about, and that's why in these live lessons we try to do a real-world application to see how we modify the logic we already understand. So sometimes you just need to write this down in plain English and say this is what I want to do, and then figure out how to do that in Python. Now we have the insertion sort here, and now you want to pay attention for assignment 8 for those in batch A, because one of your requirements will be for you to have several files like this and be able to import your functions into the app. So we have our insertion sort helper function that we want to use and the selection sort, and we want to work on this lab here. So we have this data set here, and who can tell me the first thing we want to do to use the insertion and the selection sort?
Can you repeat the question? I didn't hear you.
Who can tell me what you will do to use the insertion sort and the selection sort? If you don't understand, ask me to go over again, because it's important you understand, and nobody should feel left out or feel like you cannot ask a question or your question is not good enough. The more you ask questions and the more confused you are, the better you become, because confusion shows that you are thinking critically and you're trying to make sense. So anybody with question, just keep asking. If we need to have extra time, we'll have extra time. Okay?
I think for insertion sort, like you have to like assume the first elements that it's already sorted.
No, we've already handled that in this algorithm, so we don't need to think about that. But what do we do to use these two files on this file? So we want to import. Remember your modules in Python? So you want to import. So we want to import this function from this selection sort file. So in Python in modules you say from, we just want to import from selection sort. So say from selection sort, it's just the name of the file. The name of the file is selection sort, but you leave the .py out. What do we want to import from this? We want to import the function that we call selection sort. So from selection sort, import selection sort. And the reason we use from, instead of just saying import selection sort, which you can just do directly, that means you're importing this whole file. But instead of doing it like that, we just want to import what we need in the events that you have many functions on this and you just want to import only one. So from selection sort, we import selection sort. We'll do that for insertion sort too. Okay, so say from insertion sort, import insertion sort. All right, so we have that imported. We have the data set we want to work on. We can have this data set on a different file, and we can say from products import this variable products if we want to do it that way. But I'll leave it on this file and you figure that out in your assignment. Now, the first thing we want to do, we say we want to sort this by price. Now, our selection sort here, we have a key, so we'll just pass in the key. So we'll make it easy because we've handled that in our algorithm there. So let's say sorted by price. And this will now be equal to selection sort. And in the pair of parentheses, we put the data set, the array that we want to sort, which is product. And then the key we want is price. So you see how easy it is? And now, well, say we want to sort by stock in descending order. We did the insertion sort and we handle descending order here. So we know that reverse is false. We can set reverse to true. So let's say sorted by stock price, right? Or by quantity in stock. So sorted by stock, and let's say we want to set this in descending order, is equal to insertion sort. We are sorting the product data set. We are passing the key to be stock, And then we are saying reverse is set to true. Okay, reverse is equal to true. So now, does it make sense now as we are using it?
Yes.
Yeah.
I'm kind of confused about kind of confused about this. Wait, can you go back to the selection sort page?
Okay, look at selection sort. We pass in the array. In this case, the array is the product as the list. We have this list of dictionaries here. Now, for lesson 1 of Python for data science, this is going to even become clearer. So we start Python for data science on Monday, 24th, and our lesson 1 is going to deal with return types, and we'll see how we test and how we validate for production. And you see this having a list of dictionary, all of these things that you have to think carefully to see how do I get to the second item in this list and get the key. We'll handle that in the first lesson of Python for data science. So you can see that all the courses are building on top themselves. You can go back to your Python fundamentals and look at modules and see what modules we have and expand your knowledge on different functions. Then you can look at the different data types, the lists, and we know in Python we use list as the array. And then you can look at functions also and look at the different types of arguments. You can have keyword arguments and just the normal arguments, that's positional arguments also. And so those fundamental knowledge helps you to think. And even while we are doing this, we are not still writing this function for production, because production you handle return types, you handle several things that you will see as we do the advanced course on Python for data science. Now, every app you build, I mean in modern times, is going to be an API. You don't know in advance what you are going to return from that API. But you know that API, if you are using a RESTful API, is going to be a JSON file. We have a JSON module in Python, and we've already looked at in the Python fundamental how you use modules and you use things from a module. And so you can look at the different method and function in the JSON module in Python and see how you can pass this to Python dictionary. And so you see why the sequence data types are all important. We also have another module that we call the collections module. And we'll see that as we look at the tree data structure for the, or not the tree data structure, maybe week 11 content, where we look at the graph data structure. But we'll also use that for stacks and queue. All right, so these are things you need to go in deeper, and you always have to refresh your knowledge on Python fundamentals. We'll see if we'll fix additional live class where we'll just go through fundamentals of Python so that this concept begins to stick. Because in app building, what you need is to be able to assemble every fundamental you've learned, because there's nothing new you are learning here. You are just learning how to assemble all the fundamental concepts that you've learned. Okay, so is it making sense?
Yes.
Good. So now we have stored this in a variable. We just want to print it out. So you can format your printing out to make it look beautiful, and say you want to loop through the items of each dictionary. You can just print it out like this, sorted by price. Let's print out sorted by price and you see how it is. So if this was going to be on an interface, you want it to look like this, to just come out like this on the interface. See, name, USB cable, price. You want to display it beautifully, maybe even in a table, and you have a table in your front end where you now put in these variables so to display the values of each item. So we can try to format here and say, let's say product sorted by price, and let's say this is in ascending order. Okay, and we want to format this and say for products in sorted by price, you want to print, let's print the, I'll use the format string, so we can say the name is, we know the name is product and the key name. We want to get the price, will be product, the key is price, and we want to get the stock. So if you don't need to get the quantity in stock and you just want to get the sorted by price, you can just put the product name and the price. So we'll see how it is sorted out and forget about the quantity in stock, like that. Okay, and then let's print this out. So it depends on what your requirement is. So when we print this out, we can see products sorted by price in ascending order. So you can see that the price is in ascending order, but in this data set it is not. See 25, 49, 8 days, but here it's sorted out. The lowest price, 8.99, comes first. So you can see that, right? And I'll tell you one app that we all use, or most of us have used, that uses this algorithm. Okay, and who can tell me one app you can imagine that works with this algorithm? One app that's commonly used that works like this to sort things by price and all those stuff.
Amazon?
Yeah.
App.
Yes, like e-commerce sites like Amazon, Shopify. Now, this whole algorithm will be modified to use the graph data structure that we'll see or we'll use a tree data structure and even graphs. Now, if you go to these large e-commerce sites like Amazon and the rest, they will not be able to be efficient using selection sort and insertion sort. Why? Because the data set is large and the number of swaps that it will take to get this, and we'll see how we can compare selection, insertion, see which is better by looking at the number of swaps it takes for the same data set. And then we will now move into week 10's context when we look at tree, and we'll do a lab on the tree data structure and see how Amazon can use the tree data structure. And when we go to week 11, we'll change that to using the graph data structure and see how it's even better as we go along. Okay, so yes, Amazon is one place that we use this, but it will not be practically optimized because of large data set, because the number of swaps you need to do is, if this is not fairly sorted and they have millions of products, then it becomes very slow. So when you see, like, you go to your Amazon site and you are looking for let's say for instance you're looking for light bulbs, and you see on your left side you see things like you want to sort by price or by review, or you want to sort by so if people have 5-star review, or you want to sort by the product's name. So you see that you just click and automatically gives you in ascending or descending order of what you want. So if you say you are looking for a price range, you don't want any light bulb with more than $10, so you say between 5 and 10, it only gives you all the products that falls in that price range. So those are the things you can do like that. So now we've seen this, and we can also print out for the stock in descending order. We already put it here, sorted by stock descending, and we're going to say, let's just do a formatted print product by stock, and we want this in descending order. So what I'll do is I'll try to copy these files into a note and send it to you guys to watch along with the video. It's not easy to become a developer because the thought process that goes into it. Some days you get discouraged, you feel like you've been learning and you're not getting the point. But the more you imagine and build apps, and that's why you see most of our assignments are labs, the more you get comfortable and you'll be able to work on real world scenarios. And for those who have done internship with us before and you're waiting for full-time employment, you can join the internship from January to that starts in January, and the internship this time is going to be 3 intense months of training, January to March, and then paid from March. But for those who are already senior interns before, joining is just to keep yourself knowledgeable, especially that we are doing more advanced things and teaching what we have not taught in class, and it does not affect your full-time employment in the future, or it doesn't make you an intern, but it's just to keep yourself going. So for those who are here and you want to reapply for internship, you can send an email to put your to put yourself in that position where you keep learning on real world app until you are until the position becomes open and you are fully employed and you keep yourself in a position where you can actually pass technical interviews. And in the future also, we're trying to make connections with other companies where they will hire directly from our school or our top students, seeing how we try to make sure everybody knows what they're doing and they'll become like an asset to a company. So if you want to, if your internship is ending December or already ended, you can decide to join internship while you're in training from January to March. And you can still continue with the internship program if you want, even when your full-time employment starts. Keep yourself learning. All right. So we're going to print. So for this one, we want to print in descending order. We've already stored it in the variable sorted by stock in descending order. We just want to print the name and let's print everything, name, price, and stock. So I'll use the format string and I will say the name, just same with the last one, product name, the price, we have product price, and then we have the stock, and here we have products stock. So let's print this. And so product by stock in descending order. So we have the stock 150, the highest is 150, the next is 30, 18, 12, 5. So we see like that. Here, highest is 150. We move this cable, USB cable first, and that's what we have there. So you see how we do it. So you can actually add sorting by name. That will be very easy for you to do, to sort by name. You can add you can count the algorithm comparison and swap. We can quickly do that so that we can move to the next topic and not be out of time. So let's say we want to add comparison. I'm going to remove this. I'm thinking of the fastest way to do this, and let's clear this. I will try to get you this file of this code or rewrite it so that you have everything on one file and you can have the notes for this. Okay, so we want to add sorted by name, right? So say sorted by name will now be equal to, so let's use selection sort, and we want product and the name. So we can say, let's print this out. For product in sorted by name, we want to print out, we use the format string and we'll say the name will be product name, and then we have the price will be product price and the quantity in stock. So let's say stock will be product stock. Okay, so when we do this, So we sort by name. So we do alphabetical order A to Z. You see K, L, M, U, W. So it's sorting by name. All right. So we can do a comparison count for both algorithms. We have let's do selection sort with the count. Now I'm thinking of how to add count in this without us rebuilding the selection sort. Let's say here we want to have count. Let's have a global variable that we can access from anywhere here. So let's say global count comparison. And let's count the number of swaps. So we want to count the number of comparison and the number of swaps, right? And we'll leave this like this. And when we do for I in range n, and we do for j, so this is where the comparison and swap start from. So let's do, after this is comparing, right? So let's say count comparison plus equal 1. All right. So we have when we do that, let's say count comparison and count swaps here. Let's make it at the top here. We have the variable count comparison, and we'll set it to 0. And we have count swap, and we set it to 0. Like that. Does it make sense? So we are trying to do a test to see the number of swaps and comparison when we use selection sort and insertion sort. And so when we now make this variable global, I don't think we need to do it here, but let's just go ahead like that. We have when we compare, so this is the first comparison, you increment for every iteration of this inner loop. We want to do that. And then at the end, when there's a swap here, where we swap here, we want to increase the swaps. So let's say for us to do that, let's see, I'm thinking of when we count comparison plus equal 1, when we say if array j key is less than minimum this is min index j, we can do something here. We want to say outside of this for loop, if we have an if condition before we swap, if the min index is not equal to I, because we don't want to count that. You know why I'm saying so? You don't want to recount something when there's no swap occurring, because if we put the count swap here and increase the count swap here, it is going to falsely count a swap. So in the event where you compare and there is no swap, it will just increment by 1 even there's no swap. So we want to put another condition here and say if the min index, I hope this is right, if the min index is not equal to I, right, then we want to now do this. Then we want to say array I, you understand? So we want to check the condition if the min index is not equal to, we don't want to swap when they are equal, maybe you have duplicate values in the list and when there's no swap at all. Does it make sense?
Yes.
Then so now here you can now increase the number of swaps. So say count swaps plus equal 1. So I'm just doing this to be able to compare both algorithms. So now we can do that for the selections, the insertion sort also. So let me take this and I'll use that here. And so for the insertion sort, we will put the same thing just as we did here. Let me just copy this whole insertion sort here. And let's see how we can have all the functions on one file. So we have that here. We'll still make this global here. So we'll have global. So on this place now, we'll be importing selection insertion sort and will not have anything from the insertion sort file. So you understand what I just did? I have insertion sort function here also. Does it make sense?
Yes.
Yes.
Okay. So here now I want to. So who can tell me where we are going to increment the count comparison and when we are going to increment the swaps?
Then I didn't hear you.
You said?
I did not hear what you said.
Where are we going to increment this count comparison like we incremented here, right? And where are we going to increment the count swaps here?
So count comparison will go in the while loop.
Exactly. So in the while loop here, we'll say count comparison plus equal 1. And then in the... Why is it giving me the red wrinkling line?
It is before line 30.
Sorry. You see, my brain is already sending out smokes. Yeah, so it's going to be here. Now somebody is paying good attention. That's beautiful. Okay, so where are we going to do the count swap? So now for the count swap, we have to be careful like the other one so that we don't count when there's no swap, right? We have done this while now we can change this. Let's change this whole place, this whole part, so it will be easier. So let's say while j is greater or equal to 0, I want to change this to c, and then we going to increment the comparison here, and then let's use an if condition here. If, like we did the last time, if array j, so you see I'm trying to make it like this just so that there will be no count of the swap if there was no swap. If array j key is greater than current key, let's even forget about the, okay, no, we'll put the reverse. No, let's do it like this. So if array j key is difficult to think while working and not reverse, right? I think this is what we want to do. Because we set reverse equal to true, let's say not reversed, right? And not reversed, and or let's use an or condition, or the array j key is less than the current key. And let me put this down so we can see it properly. Don't come format this well. It's less than the current key and reversed. Then before this condition, then array j plus I is equal to array j, then we'll say j minus equal 1, and then now we can count swaps, right? Plus equal 1. When you think through it, the logic will become clear. And if there's no swap, what do you want to do when with the if condition? We'll use the else, and then we'll just break instead, exit the loop. So you see what I'm trying to achieve here? I'm trying to make sure that if there is no, if it's already sorted. So you see this condition here, and that's why I say two developers might think about the same thing differently, and this will help you to optimize your code. So now we have modified the insertion and the selection sort. We can now do our sorting with count. So let's say here we have sorted by, let's do sorted by price with count, then sorted by stock with count. So we have sorted by price, let's put with count, and we're going to use the selection sort. This selection sort here has, we already have the count added to the selection sort. So we'll say selection sort, product and price and let's do the comparison here. Let's say print, and we're printing selection sort comparison, and we want to have the count comparison, we want to have the swaps. Okay, then for insertion sort, let me remove all of this. We want to get we want to have the stock in descending order, right? So say sorted by stock descending. So sort this by stock in descending order with count. Let's say, and this will be equal to insertion sort. Let's say insertion sort, and we're sorting the product and we want to sort this product stock, and now we'll set reverse is true. Now we'll print out insertion sort, let's comparison, and this is going to be count comparison, and we have the number of swaps will be count swaps, and then we can now use the time function. Here we can say we want to import time, right? And when you import time there, you can now start time. Let me just do everything and I'll explain it. So the time module is another thing. I think we just touched skeletally on it in the Python fundamentals. You can go back to look at the time module and see the different functions or methods that it exposes you to. So say sorted by price, and let's say timed is equal to selection sort or the product is sorted by price. Then let's do the end time. The end time here will be equal to now let's go to print the selection sort time. Let's start on a new line. Let me put it to a new line. Selection sort time, and this is going to be the end time minus the start time. The end time minus start time, and before we did the start time sorted by price selection sort. Okay, so let's do it like that. let's make sure that this is formatted. Let's say end time minus start time, and let's format dot 10 f, and we want this in seconds. Then let's do the start time for the insertion sort. So we just time function. So once you are developing, this is part of the things you will do to test your functions, especially when we're separating front end from back end. So let's say performance counter, and we have sorted by stock, descending with count, let's say descending timed. So we don't have the same variable names, and this we want to use the insertion sort. So we want to compare both selection sort and insertion sort and see which is better. So stock, and we have reverse equal to true. So we're using the insertion sort and the selection sort, and we want to compare the two and see which one has a faster time. The time function is not usually the best to check because it's subject to even your hardware, the number of programs running, but it can still give you a fair idea, especially when the difference is large. And we want to do that and see the number of swaps, the number of comparisons that occur with the same data set. Then you can now use that to evaluate correctly which sorting algorithm is better. So now let's get the end time here. It looks like I've made a mistake. Well, when we test it, we'll see and then we trace back. And this will be time. So you do the time when you start and the time when it ends to see the difference in time. And so we'll print the difference in time. Difference in time now will be, let's say, insertion sort time will now be end time minus start time, and we're going to format this second. Okay, so now let's test this and let's correct our mistakes if there's any. So when we run this count comparison swap, count comparison is not defined comparisons. So we did not import the count comparisons on count swap. Okay. So instead of from selection sort import this, we'll just import selection sort and we'll have access to everything. But we'll just use it like this. So we can see it's working well. The first one, we see selection sort, comparison 0, swap 0. So something is not right because the comparison should not be 0, the swap should not be 0. The selection sort time, it takes this second. Insertion sort time, look at the number of seconds. So for the selection sort seem faster. So let's see the number of comparison and swap. Let's see why it is not, it's giving us 0 here. We looked at we modified this function. Let's say selection sort. We have count comparison is 0, count swap is 0. Oh, the problem we have here is we are using the same counter for both. Let's use this on its own file. It might work better like that. And then okay, let's see here. We're importing so let's see, import selection sort, import insertion sort. Let's see if this fixes it. product price. Yeah, so the problem with this is when you import it like this, when you want to have this selection sort, we're importing selection sort from selection sort. So you have to put selection sort dot selection sort, and here you have to put insertion sort dot insertion sort. You understand what I'm doing?
Yes.
And insertion sort. So just importing only the function you need makes it easy to just use the function name. If not, you have to put the module name dot the function name. So let's see. Count comparison swap. Oh. We have not imported everything. Import selection sort. I'll do this from. Well, you know what? We'll make it easier. We'll just copy this here and put it here at the top. But it's not the best. We want to save time because we still have another agenda. What did I just copy here? Is it insertion and selection? Selection. So I'll do insertion too. Let's run this. Selection sort dot. Yep, I have to remove all the things I did here. Remove insertion sort. So you still work on different files, and when you play around with it, you'll see how you import them without having this conflict. Okay, I'm doing this to make it faster. Time dot. Oh, we're going to import time. Import the time function. Now we can get it correctly now. So we see for selection sorts, there are 10 comparison, there are 2 swaps. For insertion sorts, there are 18 comparison and there are 7 swaps for the same data set. So you can see how many comparison and how many swap that it takes to use each of the algorithm, and this will now show you which is better and which is not. Okay?
Yeah.
So does it make sense?
Yes.
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 Yeah. So I'm going to stop this here, and you can see selection sort, the number of seconds it takes, and insertion sort, and we can see insertion sort is faster time, but the number of comparison and swaps. So now you can make a decision based on the cost of each of them. But for large data sets, you see that this is not applicable. It's not what you want to use. Okay, so you can look at this and see selection sort in the best case will always be quadratic, n square, because what we have here is the number of items 1, 2, 3, 4, 5, and for selection sort is squared, like the double of it, n times 2, right? It's always quadratic, double the number. So if you have 5, you have 10 comparison. If you have 10, it is going to be quadratic. It's not going to just be double. And then for insertion sort, it's only very fast when nearly sorted. And this is not for insertion sort here. We use insertion sorts to do the stock in descending order. And because we are doing in descending order, it's not nearly sorted. We can see the number. But if we decided that we want to sort the same by name and compare, then we can see very well which is better. Okay, and so in the best case, insertion sort will always be better in the best case, but both of them have the same worst and average case, right? And in practice, the differences are just minimal. In difference, look at the number of seconds it takes. Selection sort takes this, insertion sort takes this. Insertion sort takes smaller number of seconds, but it's still minimal. 2831, it doesn't really count for anything as much, right? And the number of comparisons that we can see here in this, we can see for this case the comparisons are different. Okay, but when it's nearly sorted, insertion might be better or slightly faster, but for large data sets you don't want to use any of those two. Okay, so I'm going to copy all this code and send you the file along with the video later on. Let's do the next agenda on the list, which is the binary search tree. Now we have pre-recorded videos that I'm very sure you will not understand as much, but you need to look at how we can do the array implementation of binary tree, especially when you are going to do more frequent reads than all these other operations and insertion and deletion operations. So if you are doing a lot of read and you're not modifying your data, you might want to just do your binary tree, the array implementation, which just involves, when I say array implementation, it just involves using the built-in Python list to do that. We have that in your pre-recorded video. We also have that in your notes, and so we're not going to go into those parts. So I want you to look at those videos and your notes to work on that. And then we look at the binary search tree, and we say that is a special type of binary tree that has, so in that tree each node will have at most 2 children, a left child and a right child. Now when you have the left subtree, all the nodes on the left subtree, the keys or those values you have there are less than the parents, and all the ones on the right are greater. So all the items that are less. So you have a tree. Let me clear this and let's go there. So let's do something here. You have a tree, and everything to the left. So let's say this is a tree, this is a parent. This parent is 7. Everything to the left of this is less than 7. Everything to the right is greater than 7. That's how a binary search tree is. So the worst case of search, insert, delete is always big O of n, the number of items. And binary search tree is very easy to use, it's very efficient, and you can make it even more efficient by balancing the tree or having an AVL tree. And when do we have AVL tree? We use AVL. AVL is just the name of the authors, but it's just called like a balance tree. When you have a links list, you have item that exists like in a chain. It has a pointer like this. The search and delete operation will not be as fast as when you have it in a tree, where all of the items on the left are smaller, all on the right are larger, and it is balanced so that the tree is not skewed, like is right heavy. The right has several subtree, the left have only one child or something. So you want to balance it by doing rotations. And in our pre-recorded video, we looked at how we use AVL tree to balance. I also have a lab in the pre-recorded in the lesson notes where we try to implement a product catalog search engine, a real world app. I'm not going to repeat that because you have a full code to be able to build a product binary search tree class. You're able to add sample product IDs. You're able to ask for a user or ask a user for product ID. You're able to remove a product that is no longer in stock. You're able to display updated catalogs. We are not going to do that, but when we have time another day that we want to do a review, we are going to go into those labs that you already have. So I want you to have a wide range of examples. It's very important for you to read carefully your lesson notes for week 10 and look at the pre-recorded video, and then come back to this. Let's build a totally different app here. Now we have 2 apps that I planned for today, but we have less time because we'll have another class in 20 minutes. One of the apps is to build an order management system where we will use a binary search tree to manage orders. And the second app that I would have loved to do is an app for students. Let's say we want to create a student record binary search tree. Let's do the student record one because you are going to complete it as your assignment, your assignment 8. Now, the student record management system that we want to build will use a binary search tree. Let's have this here. So let's say a school wants to build a student record management system where each student has unique student ID, and the student ID is an integer. We want a system that can add new student records. We want a system that can search for a student by their ID. We want to be able to delete student records when a student graduates or leaves the school. we want to be able to list all students in ascending order of the student ID and to be able to retrieve the student with the lowest ID. So we want to have like the first student in the registry. So we want this app to support fast searching and sorting and sorted listing, and we want the system to use the binary search tree. Now, how does this relate to real companies? Now, we know now that Amazon uses tree-based structures for sorting and retrieving orders when they want to sort, and then they will use graph for recommendations. We'll look at graph in week 11, but tree-based structures for sorting and retrieving for most large e-commerce sites. And even when you have logistics systems for fast search structures and lookup, like for shipment IDs, trees are used. Banking system also use tree indexing to track transaction IDs. So at the very best, we have, or even at the worst case, we have big O of log n expected performance for data sets like orders. Order data set is the one that is very dynamic and changes all the time. All right, so let's look at this student record and let's see what we can build out of this. We want to, let's see what we'll do now. Hold on. Let's create a class. Let's use object-oriented programming. And we want to have a class that will create the binary search tree. We want to have a class, and in that class we'll have a method that will add students, search students, delete students, list students, and maybe get the first student. That's what we want to do. So we implement a node class first, and then we do an insert example. Let me try to see how I'll think about this. So the first thing we'll do is to create a class. Let's call this the node class, and let's say init. Okay, so now we want to be able to create an object of this class, and it's in the object where we'll pass it a node. So let's say self.value is equal to value. We want to have the left is equal to none, and then we have the right is equal to none. Okay, now let's create the class for the, let's say, student record binary search tree. Let's call it this. And the init method, let's say this will just hold the root, right? Init, we self, and then we initialize the root to be none. So we've done this basic one. We have the node class, and we have a class that holds the student record. Now, or the methods that we'll use to manipulate the student record. We want to create a method to add student. So let's call this def add student. And when you want to add student, what are you going to pass in as your value when you call this method? Who can tell me? Anybody? So when you want to add student, is the value you want to pass in. So say self and the value. When we're adding students, what are we adding? We're adding the student ID, right? So if there is no root, or if this is not root, because self.root is none, so there is no record at all. So let's say if not self.root, we want to create an object now, and this object is going to be the root, and the value is going to be the value. So we're going to be having an object of the node class here. So we'll say self.root is equal to node value. Does it make sense?
Yes.
So this becomes the first item, will be the root. So that's the first one. But if there is a root, we want to just add student. So we'll recursively call this. Now we can create an add student method, a private method that will be a helper function. Let's do that like this. You'll see that in your pre-recorded video. Let's do that. So every time I put an underscore before a name of a variable, it's just intended to be a private method that is just used within this and not going to be called. Let's have the current, the value, so that this will know where to add it to, whether on the left, on the right, and something like that. And we'll say if the value is less than the current value, we are putting it sorted order. And sorted binary search tree is always sorted because the lower values, that is everything less than the root or the parent to the left, everything greater to the right. So it will have the left children and right children. So if the value is less than the current value, we want to check again if the current left. So say if the current was left, if we're on the left, we want to recursively do this. Self.addStudent current dot left value. Right, else current dot left. Okay. So this private method is to help us to call this add students and use this private to just conclude the add students, to add a student to the list. Else, if the current dot right, then we want to self dot add student, and we'll have, I'm going to extend this again, current dot right and value. Next week we're going to actually repeat this because next week's content is not as bulky, and so we'll be able to repeat this before your assignment deadline and you understand it properly. Okay, but I want you all to watch your pre-recorded videos and understand the basic concept before coming back. So for the binary search tree, we said that you have a parent node, all the key for the parent, everything that is less than. So when you want to insert, you look at the existing one, that is the parent. So you create a left subtree, everything less will go to the left, everything right, everything greater will go to the right. Now if it's out of balance and maybe the right is longer, is bigger than the left, or heavier than the left, has more height than the left, you might want to balance by doing a rotation. And we looked at that in the AVL tree when we do one of 4 types of rotation. You see that in your pre-recorded video. But we're creating this method here to say we want to add the students, and while adding the students we want to check the left and the right, and so that we can be inserting this in a kind of balanced fashion to say that if we get the current value, right, the last place we inserted into, so that will be like the root for that subtree or the root of the whole tree. And if the left part of it has records on it or has items, you want to add those items if the item is less than that current value. But if it's not the case and the current value is greater than the value you want to add, you want to focus on the right subtree. That's what we are doing here for the add student. And then here now, for this add student method, we can now just call this private method to insert it. Dot add student self dot root and value. Okay, so here is, if it has no root, you want to just create that value as the root. But if it has a root already, you want to use this private method to look at the left and the right, do all the checks and insert it. So this is exactly what you have in your notes and your pre-recorded video. And then we want to create a method for searching, which is the same thing you should have had in your notes too, where you can create a private method to search if the item you want to search is less than the root, you know that you're searching just the left part. If it's greater than, you know you're searching just the right part, and you recursively do all the lefts of trees. In the event that it continues to be less and rights of trees, if it is right at some point. Does everybody understand?
Yes, getting it.
Okay, so you'll use that method to, like what we have in the pre-recorded video and in your lesson notes, to do the search. You have the private method and what you use. So you have a current value to search both left and right, depending on whether it is equal, less, or greater. And then delete is going to be the same thing. And then you're going to create a method to get the first student. I know the first will always be like the root. And maybe a method you want to list students. You want to do your in-order, post-order, pre-order traversals that we have there. And then you can compare this to say, let's work on the add student now. We're going to test just with the add student function. So let's say the student is equal to, let's say their student's ID is just digits like this. Okay, so let's have this. So we can create an instance of the class student record BST. So say is equal to student record BST, and then let's insert student here. So say for S in, we want to insert in a loop, right? For S in student, we'll say the method is add student. So we'll say BST dot add student, and then we'll pass in the iterator S, so the value we're adding the S. Okay, so we don't have a method to list students. Maybe we should create that to list students so that we can print the list of students out. So let's say def list students like this. Self, sorry, and to list the students we want to, let's use a list. Result is equal to a list, and let's say we want to do an in-order traversal. In order, you visit the left, then the root, then the right. Let's create an in-order private method. Let's say def in-order like this, and self, we want to look at the node, the result. If node, we want to print self dot, we'll just recursively call in order node dot left result. Then we visit the root, result dot append node dot value, and then we'll do the right, self dot in order node dot right result. Okay, so your pre-recorded video will explain to you this traversal method. I think, does everybody understand the traversal? You've seen it in your videos, right?
Yes.
Yeah. So I'm just going to use it here, and I'll say result is an empty list here, and then I'll self dot, I will call the in order. So just do the traversal for me. So self dot in order, I will pass in the root, and I will pass in the result. I think this is what I should do, and then I will return the result. Well, we'll test this and see if it doesn't work, and then we'll retrace our errors. So here I want to print out the student list, the initial student list, and it's going to be sorted. So let's say print initial student list, and we know it's going to be sorted because it's a binary search tree. So we'll have BST as the object of the class, BST dot the method name list student dot list student. And so let's run this and see. Now we have BST dot list student, line 49. Okay, it's on line 39, self.inOrder. It's the private method here, inOrder. Okay, so I'm going to clear and run again. Okay, now it works. So we wanted to insert all of this, and we can see that when we use the inOrder traversal, it inserted this and brings it out in sorted order when we list the students. Can you see that?
Yes.
So
Yes.
this is similar to what you already have in your pre-recorded video and in your lesson notes. For the week 8 assignments, I'm going to explain that to you. I'm going to have the full code I'm going to put in your assignment file, I'm going to put the full code to add the students, like what we just did now. To search for a student, I'll put the code to delete a student and to retrieve the first student in the school registry. And then you can also a code for you to be able to print out the updated sorted list of the students. When I give you that code, I want you to enhance the code in your assignment, and there are several things I want you to do with it in the assignment. We want to, instead of storing only the student ID in the assignment, you will want to store both the name, the class or the grade. You want to store the GPA and the email. I will also want you to modify the node to store a student object. Okay, this node will be modified to store a student object. That will be part of your assignment. You add an update feature in your assignment, and what we just did in the insertion and selection sort, where we have a separate file, I'll give you a CSV or JSON file, or you create a CSV or JSON file where you load the record. So here we have this, you put it in a different file, and you see how you can just import the name of the variable from that file. And so you're going to load the student record from an external file, a JSON file. In this case, it's going to be JSON, which is going to be like dictionaries when you pass them. And then you will build like a menu-driven command line interface program. And in this, your command line interface, where you have a prompt, you want users to pick an option, just like we did in last week, where they'll pick option 1 to add students, option 2 to search students, option 3 to remove students, 4 to view the sorted list, and maybe 5 to exit. And if you recall from our last lesson, we did all those CLI driven programs. So I'll detail this in the assignment explanation for you to create a file. You call this file students.py, and you will use things like generators and the rest as much as you can do. And in that student.py file, you have the student class that you will have the student's ID, the name, the grade, the GPA. Then you want to have the student node file, and there you have the student node class. You want to have the student binary search file where you have the student BSCs. So this, what we are doing here, I want all of these classes in different files in that assignment, and I'm going to detail it. And then you're going to put in this all the insert, update method and everything based on the code that I've given you. You're going to extend that code to add those GPA and the rest. Then the menu-driven CLI that you're going to build, you're going to import all of the files in one file, and you're going to have a prompt where they will choose an option, what they want to do. If they want to add new students, you know what to run, what function you want to run if they're adding new students, and you ask them for the inputs to be able to put in what they want to add. So you build that CLI based on that. All right. So last week's lesson and the lessons for today will guide you, and I'm going to send that file on Monday, the assignment file for assignment 8, and I'm going to complete this code and for all the other functionalities that you're going to use for the assignment. Now, before we go, does anyone have any question?
No.
So we are going to review this again in week 11, along with the graph data structure that we are going to do in week 11, the next live lesson. And should you need any additional lesson or you feel you don't understand it, you can let me know in advance, and we can have an extra class on another day to explain it in detail. But you first have to watch this and the pre-recorded video so that you are able to understand it better. All right?
Yes.
Yes.
All right. So thank you, everyone, and see you all next week.
Thank you.
Thank you.
Thank you.